Now today we're going to be talking about Bohr models. Now, Niels Bohr took Rutherford's atomic theory and proposed a model in which electrons surrounded the positively charged nucleus as the planets surround the sun. Now this is called the Bohr model, which the protons and neutrons are the center, called the nucleus, where electrons are orbiting around it. And each element has their own number of orbitals, which is based on the row number they are located in on the periodic table. Okay, so depending on where they are on the periodic table, that is the number of orbitals they have. Now each orbital has their own energy level, and the farther the electrons or orbitals are to the nucleus, the higher its energy. So with that being said, let's go ahead and do some practice problems of figuring out how many orbitals each element has. Now first we have helium. Helium is in row 1, so helium has 1 orbital. Now looking at lithium. Lithium is in row 2, so it has 2 orbitals. Aluminum is in row 3, so it has 3 orbitals. And Fe, which is iron, is in row 4, and it has 4 orbitals. So with that idea, each orbital can hold a certain number of electrons. So looking at row 1, we have 2 elements. Since we have 2 elements, that means our orbital 1 can only hold a maximum of 2 electrons. Looking at row 2, we have 8 elements. Since we have 8 elements in row 2, orbital 2 can only hold 8 electrons. We also only have 8 electrons. That means our orbital 3 only can hold a maximum of 8 electrons. Row 14 has 18 elements. That means orbital 4 can only hold a maximum of 18 electrons. And that is the same for row 5. We have 18 elements, so row 5 can only hold a maximum of 18 electrons. So with that idea, let's go and do some practice problems of drawing out Bohr models. So we're going to draw the Bohr models of the following elements. Problem number 1, we have helium. Now, looking at helium on the periodic table, helium is in row 1, therefore helium only has 1 orbital. So now, before we do our Bohr model, we have to figure out how many protons, neutrons, and electrons helium has. So we have to look at helium square on the periodic table. Now, helium has an atomic number of 2. And if you remember, atomic number equals number of protons. So since the atomic number is 2, the protons 2. And from right now, if you remember, we want our protons and our electrons to equal. So since we have 2 protons, we're going to have 2 electrons. Finding the number of neutrons, we got to take the atomic mass whole number minus the number of protons. Helium has an atomic mass of 4.003. We have to round it to the whole number. So we look at where the decimal point is. The 0 tells me the 4 stays the same, so rounded to the whole number is 4. So we're going to take 4 minus 2 from the protons, and that equals 2 neutrons. So we have 2 protons, 2 neutrons, and 2 electrons for our Bohr model. So now we're ready to finally draw our Bohr model. First, you're going to draw a solid line circle. That is going to represent our nucleus, which is the center of the atom. And if you remember, our nucleus is composed of protons and neutrons. So we have to write the number of protons and neutrons in our center. And we have 2 protons and 2 neutrons. Now we've got to draw our orbitals. And helium only has 1 orbital, so we're going to do one kind of dotted or dashed circle around the nucleus. Because orbitals are actually invisible. There's no actual orbit, orbitals like rings, like Jupiter does on its planet. These are more invisible. So that's why we want to represent it as dotted or dashed lines. Okay. Now all of our electrons are going to go into our orbital. And we have 2 electrons, so that means we're going to have 2 electrons on our orbital. And this is the Bohr model of iron. So moving on to problem number 2, we have lithium. So looking at lithium on the periodic table, lithium is in row 2. That means lithium has 2 orbitals in its Bohr model. And now we got to find the number of protons, neutrons, and electrons. So looking at the element square, lithium has an atomic number of 3. And if you remember, the atomic number equals the number of protons. Since the atomic number is 3, the protons is going to be 3. And remember, we want protons and electrons to equal, so we have 3 electrons. Now we have to get the whole number of atomic mass to get our neutrons. Our atomic mass is 6.941. We have to round this to the whole number. So looking at our decimal point, our 9 tells me our 6 goes up to 7. So we have to take 7 minus 3 from the protons, and that equals 4 neutrons. So we have 3 protons, 4 neutrons, and 3 electrons for our Bohr model for lithium. So again, first thing we got to do for Bohr models is draw our circle, because that's going to be our nucleus. Protons and neutrons are in our nucleus, so we have 3 protons and 4 neutrons. Now lithium has 2 orbitals now, so we want 2 dotted or dashed circles around that nucleus. Now helium only had 1, now we have to have 2, so where am I going to put these 3 electrons at? Our second orbital is our outermost orbital. We have to maximize the number of electrons of all of the orbitals inside our outermost. So in this case, this orbital here we have to max out. That is orbital 1. And if you remember from before, we have to look at how many elements we have in that row. Orbital 1 is row 1 on the periodic table. There's only 2 elements on row 1 of the periodic table. Therefore, we can only put 2 electrons on orbital 1. We cannot put any more on there. So we have to treat this like Legos. We have 3 pieces of Legos. We just used 2, so we have to find our leftovers. So we have to take 3 minus 2. We have 1 electron left over, and that goes on the outside. And that is your Bohr model for lithium. So with that same idea in mind, let's go ahead and do problem number 3, which is iron. Now looking at iron on the periodic table, iron is in row 4. Therefore, iron has 4 orbitals. And now we have to find the protons, neutrons, and electrons for iron. Iron has an atomic number of 26, so it has 26 protons. And remember, protons and electrons have to equal, so we also have 26 electrons. Now looking at our atomic mass, which is 55.845, looking at where the decimal point is, the 8 tells me the 5 goes up, so we have 56 as our mass. So we have to take that 56, subtract the number of protons, which is 26, and 56 minus 26 is 30. So we have 26 protons, 30 neutrons, and 26 electrons. So now we have that information. Let's go ahead and draw Bohr models. First, we got to do our nucleus, and protons and neutrons are in our nucleus. So we have 26 protons, 30 neutrons. This time we have 4 orbitals. Just like we did in problem number 2, we have to make sure all of our inside orbitals, orbitals 1, 2, and 3 in this case, has to be maxed out. So orbital 1, we know there's 2 elements in row 1. That means it only holds 2 electrons. That's max. Orbital 2 is row 2 on the periodic table. We have 8 elements in there. That means we can only hold a maximum of 8 electrons in orbital 2. Orbital 3 on the periodic table has 8 elements. Therefore, orbital 3 can only hold a maximum of 8 electrons. So now that we maxed out all of our inside orbitals, we have to go and subtract all of those to our number of total electrons. So we have a total of 26. We used 2 in orbital 1, 8 in orbital 2, and 8 in orbital 3. So 26 minus 2 minus 8 equals 8 electrons left over, and those 8 goes on our outside orbital, orbital 4. And that is the Bohr model for iron. So with that being said, go ahead and find the Bohr model of aluminum on your own. Pause the video, and when you have your answer, press play. And here's your answer. And that's it, guys. Thanks.